Let's make a connection here between probability and statistics. We'd already seen a tab like this where we had the original pivot table, that was the original frequencies, and we did the conditional relative frequencies, and that's what we've been working on, and the conditional relative frequencies the other way. So there we were dividing by the column totals or by the row totals, and I had grayed these out saying we don't need these right now, but those turned out to be the marginal distributions, so we'll bring those back. So that's the marginal distribution of Excel skills. And we could grade this out, and that was the marginal distribution of phone types. One thing we hadn't tried was dividing by the grand total, so let's try that. We're going to go to the value field settings, show values as, and instead of no calculation, we had done percent of row total or column total. Now we're doing percent of grand total, and we'll say OK there. And now we still get the marginal distribution on the side here, and we get this. These values are also the marginal distribution. I'm putting them in margarine color in case you didn't notice. But this 9.8%, for example, is the original 3 divided by 31. So that tells us what percent of the people who answer the survey use an iPhone or iPad and said that they have no Excel skills. And it's actually kind of hard to see just looking at joint probabilities if there's any association. You can't just say, well, this 9 is bigger than that 19. Well, that's because there were more people on the second row than on the first row. So was it enough? Is the 19 bigger enough than the 9? Well, you'd have to think about the 11 and the 7, and you're back to thinking about conditional probabilities. One way that we sometimes look at it, even though it's not so intuitive, is to say, is the joint distribution, so this is the joint distribution, is that the product of the marginals? So if I do 41% times 22%, do I get 9%? And here I've actually done those products. So if you look at this table, let's put it in percent, is that close to this table, or are they the same? And they're not exactly the same. So in a probability class, we'd say, well, since there's some mismatch, we know that this table up here is not independent. But we don't, in a probability class, talk about, well, how close is close enough, or how far is too far away. It's just if there's any mismatch, then that's non-independent. But in stats, we talk about, well, how close is close enough, and what was my sample size and stuff. So this is the real joint distribution. This is the product of the marginals, which is what the joint distribution would be if the data was independent. And that's basically how we were looking at the chi-squared stuff. We were looking at the frequencies. So instead of looking at it as a percent of 31, we were looking at sort of raw counts. You might ask, is there something like the chi-squared test we can do that's looking more at conditional relative frequencies? And it turns out rather than looking at kind of joint values, it turns out that there is, but it's much more complicated. It ends up giving the same p-value, but the calculations are much harder. So that's why we kind of use the simpler version.